Why? Please hold on. Just give me a moment. You're disturbing me.
As that has similar features, right? All right, so let's look at some of the phases for coding and planning and building. We have Git. I'm sure a lot of us that have been in IT know what Git is. Different versions of Git. We have GitHub, we have Bitbucket, which are other tools. But Git is basically like a version control system. We call it VCS. And what it does is it just keeps the different versions of your application. So let's assume you go to redluxconsulting.com and you get to the landing page, you like what you see. And tomorrow, Nonya wants to make a change. She wants to rebrand and change her application from red to blue. So the first version is V1, which is red. She works with the developer, they make all the changes, red has turned to blue, and they push that change, and everyone can see that Redlux is now blue. Um, After a while, you may make so many changes to your application or your website, and you may get confused. So that's where Git comes into play to make sure that you have like your different version of your application, all the changes that you made, all the updates that you made. You can always revert, you can always fall back to whatever version that you want. And if you also look at your applications like Instagram, LinkedIn, whatever, if you go to settings and all that, you always see version, application version .1.2.3, whatever it is. So that's how companies actually monitor and manage and control different versions of their applications. And the tool that they use to do that is either Git, GitHub, Bitbucket, Octopus Deploy. There are lots of them out there in the market. But again, if you understand one, then you'll be able to use the rest of them. All right, we have other tools like Jira, Confluence. Some of us in Agile understand and have used Jira before. Jira is a very common tool used in any Agile, Scrum, CI/CD, DevOps process. Most project managers, program managers, software developers, and all that use Jira to track and monitor tickets across the whole process of software engineering and software development and deployment. Same as Confluence, they all come from a company called Atlassian. So Atlassian owns Jira, owns Confluence. I've seen companies that use applications like Monday.com, Asana. They're all the same. It's all about managing, monitoring different tickets throughout the project lifecycle. Then we come to build. This is where the developers build the application. So just like I gave an example before, Redlux
Hi,
is red. Yep.
hi. So I wanted to ask something. You
Mm-hmm.
just because you talked about Confluence, Jira, and Git.
Right.
You talked about Git being the software for version controls, right? And then made mention of Jira and um, Confluence as different thing. Because I was really thinking that because Jira and Confluence and Git are all pointing to the code um, part of the DevOps cycle, right? That they are supposed to be doing same thing, right? So I was really thinking, okay, that if Jira is if Git is for version control and all of that, uh, is Jira and Confluence doing same thing? So just correct me if I'm wrong.
Awesome. That's very good question. Don't know who asked the question now, but great question.
Emmanuel is my name.
Yeah,
Emmanuel.
awesome. So great question, Emmanuel. And yeah, so like I mentioned before, Git is more of a version control, and the answer is no, Git and Jira and Confluence don't actually perform the same function. Um, in the process of building, so code is more like a holistic view, right? In the process of building, there's a lot of things that go into place. Like I mentioned before, Git is a version control. So practical example, we have Redlux, color red. We want to change the color to blue again throughout the project lifecycle. So version 1, the whole software application, the whole code from, the top title, HTML, whatever code, it's all stored in Git. So Git is like your bucket of storage, right? Now we have to track the process of implementing that change. So to implement that change, you have to write the code that converts red to blue. You have to make sure that it meets the specification. You have to make sure that when you push the code, nothing breaks. So you have to, yeah, it has to go through a process. The software developer won't just write the code and deploy. So managing that whole process, creating the tickets around that, documenting the acceptance criteria. So making sure that the blue is the actual blue that we want, because there are different shades of blue. And just ensuring and also managing the timeline. So how soon do we want this red to change to blue? And we say we want it done within 2 weeks. So we kick off what we call a sprint, right? So managing that whole process from that process of building to deployment, that's where Jira comes in, right? So Jira is not used to kind of store the code. But now, to answer the question of why do they all point towards the code, you can track those Jira tickets with your Git. You can track those Jira tickets using Git. So there's what we call a pull request and push request. Pull request is when a developer is trying to push those changes, right? In Jira, you create a Jira ticket. You can call it, let's say, AM101, right? And AM101 is the ticket that is tracking the color change. So when that ticket goes through the process and you now actually deploy the code, it will show in Git that this code was deployed on so day using this Jira ticket. And on that Jira ticket, if you dig deeper or dive deeper, you can see maybe comments from the project manager, comments from the business analyst, comments from the QA, to just to ensure that all the steps, checks, everything has passed before that pull request or merge request was approved in Git, right? So they all kind of interject, they all kind of work hand in hand, but they have different functions. And then Confluence is more for documentation. So I'm sure we all use Microsoft Word for, writing documents and all that. But in software development, Confluence is actually used to document. So at the end of the day, let's assume that you've written your code, you've pushed, you've merged, and one of your deliverable as the software engineer or DevOps engineer, whatever, is the company will be like, oh, give us a document on how you actually implemented this, just so that when we need to implement another solution or maybe want to deploy it to another environment, we don't have to get back to you. We can just follow that whole process just like as you documented. That's where Confluence comes into play. Git also has a README section, which people use to document as well. So you can see that they all kind of work hand in hand, but again, depending on the preference of the company, the organization, they may have to decide on what software application to use. So does that answer the question? Do you need further
Absolutely.
explanation?
Absolutely. Because yeah, at least what you just explained about Jira is what I know. So I was thinking really that something else that is speaking to when it in relation to this now, but the explanation is quite explicit about it, and it's excellently delivered. Thanks.
Yeah, welcome. And again, if anyone has questions, feel free to jump in. I'll be happy to explain. All right, so same as we used Git, Jira, Confluence as examples for code, same way we have other tools during the build stage. This is mostly used by developers to kind of build the application. We have VS Code, we have a lot of applications that we use to kind of write those codes, Python, JavaScript, whatever. Even your Notepad, I've seen people that write code using Notepad. Now, after the developers write the code or software engineers write the code, the next step is to test, right? You have to test the code, make sure that the blue is the actual blue that we want. For instance, Anya might have said she wants sky blue, and me, I'm a man. I don't know the difference between sky blue and which other blue do we have? Not, we have different shades of blue.
We we have egg. We even have egg blue,
Exactly.
navy blue, turquoise, all
And
sorts.
exactly. And we have color codes for all these colors, right? So let's assume that I'm a developer and Nonya says I want blue. And the blue that she wants is egg blue. But because I'm a man and I don't care, I just use another color of blue. Then when I deploy the code, Nonya comes back to say, this is not the blue that I wanted. The blue that I wanted is egg blue. And I myself and Nonya will get into an argument, but this is blue. Nonya will say, no, it's not blue. So this is an example of why every code has to go through testing and approval. And we have color codes as well, just to make sure that the blue that Nonya wants is the blue that as the application developer that I used. So we again remember what I said about not having a manual process. We want to automate everything. Previously, a QA engineer will have to come in and look at my code, look at the color code. For instance, black is 0000, white is 1111. I don't know what blue is off the top of my head. But someone has to come in, review the code, and look at the color code to be sure that the same blue, the blue that I asked for is the blue that I use. But what DevOps does for us is that we can automate that whole process and we can build what we call build specs and attach it to these tools like Selenium, JUnit that we use for testing. So we write out the criteria that all our code has to meet before we can accept that it passes the test. For instance, blue must be, the color code for blue. The size of the image must be XYZ. The format must be XYZ. So we can define all that in a build spec, upload that to these tools, and as long as the code that the developer has built meets those specifications, then we can say yes, that the testing is done and the code meets the specification, and it can go on to the next stage, which is the release stage. So some of the tools that we use for those testing and setting up that automated testing and Selenium, JUnit, and all that good stuff. Yeah.
Okay, just to interject, because I was just going to, something just went through my mind when you talked about maybe a disagreement about colors and all of that. So when I thought about something, I mean, because I know before a product development goes on, there are periods where informations are elicited, informations like stakeholders, requirements, and all of that. And these things are documented, right? I mean, are they not applicable here? Because in typical of a project, a project, there's a stage where you do this elicitation of stakeholder requirements, and then these things are documented, and they are eventually used, and these are what forms part of the acceptance criteria, right? So I'm asking now, are they not are those not practiced here as well? Because this is software development, like I know, and in software development, these things should be incorporated as well. Just asking in the past.
Exactly, and very good question, Emmanuel. Yeah, and before a project kicks off or a feature gets implemented, just like you said, there's a process of business requirements, right? That is mostly handled by either the project manager, the business analyst, where they meet with the team, gather the requirements, document the requirements, agree on acceptance criteria and all that good stuff, just like you mentioned. That is all done during the planning stage of the project, right? Which is actually correct, just like you said. But remember what I said, that whole process is manual. It takes someone to come in to confirm that color too. So just like you said, the color is blue. We have a color code. It's been documented. It's been accepted. We all know that yes, it's blue. The developer has built the code, has imputed that color as blue. Now, when it gets to the process of testing, right? We also need someone to confirm that the color is blue. So a QA analyst, a quality assurance engineer, a QA tester will have to go through that code, the person will hold that document that we agreed on, the business requirement document or the functional requirement document or acceptance criteria on Jira, whatever it is. The person will have to go through one line by line to say, this is the blue that we agreed on during the requirement gathering. Is that the blue color that the engineer or the software developer used in the code? Yes. We agreed that Redlocks Consulting, the logo is going to be 250 by 250. Is that what the engineer used? Yes. So you can see that this is a very tedious, long process, right? But in DevOps, you can automate that process so that you don't need to have any manual interference. You don't need to have any human interference throughout this process. And a test that might take an hour, 2 hours, a whole day, 45 minutes can run through either of these tools like JUnit or Selenium in 5 seconds, 1 second, 2 seconds, because everything is now code. Everything has, all this whole acceptance criteria and all that has been written as a code. And once the developer pushes it through this process, it runs through this code, and in 1 or 2 seconds, you get your result. And if it passes, again, remember it's automated. If it passes, it goes on to the next stage. If it fails, it reverts or rolls back and alerts the developer that, hey, XYZ was not met as defined, just like you said, in the acceptance criteria or during the business requirement document. And then the developer can go ahead and implement those changes until like it goes through the test process. Does that make sense?
Absolutely. Absolutely. Thank you.
Cool.
Question, please.
Mhm.
As a DevOps engineer, does that mean that one will be involved in all of these processes? If that is yes, which technically means that you should be able to use the tools involved in those processes.
That's a very good question. And that's the answer to your question is going to be addressed in the next slide. So I recommend you stay tuned. But just to answer the question, the answer is no. You don't have to learn everything here. And we'll go into detail the next slide and see where you may want to fall in this whole DevOps process. So just like you mentioned, DevOps engineer, there are other roles like QA analyst. We have a slide around that, and I'll dive into more detail. But the answer is no. You don't have to know all this, and you don't have to learn all this. Okay. All right. So same as it goes through the release process. Now Nonye's code has passed the test. The color has been approved to blue. So it goes through a process of release. And we have different tools that we use to kind of deploy our applications. I'm sure some of us in IT know Jenkins, CodeShip, Octopus Build, Octopus Deploy. There are lots of tools. They all do the same thing. They help package your code, right? And push them into different environments. So we have different environments, dev, UAT, prod, and all that good stuff. Depending on where you want to release, most times we like to deploy on UAT or dev environment first, just so that people can have a feel of what it looks like. Maybe internal testing goes on and all that good stuff before we kind of deploy into prod. So we have tools like Jenkins, CodeShip that do all that, and the whole process of deployment as well. Where would your application be hosted? The way Redlocks Consulting is today, I don't know where it's hosted, but I can guarantee you that at least 70% of all the applications that you use today, or maybe 80%, are all deployed on the cloud. So before the cloud, we had a lot of companies having data centers. For instance, banks, they all had data centers where they keep your information and my information, your bank statements, your username, your passwords, and your photos, videos, and all that good stuff about you. The banks have the data centers, they have, data stores, they do the networking in there and all that good stuff. But Thanks to cloud, now companies don't need data centers anymore. You can quickly spin up different resources that you need, your virtual machines, your storage, your compute, your database, all that is being done in the cloud today. And we have different cloud offerings from AWS to Azure to Heroku Cloud to Google Cloud. Again, that's why I said you don't have to know all, because for instance, if you know AWS, you can work with companies that deploy their applications on AWS Cloud. If you know Docker, Docker is a containerization tool. So what Docker does is it packages your application into a container and then deploys onto a virtual machine. We also have different containerization tools like Kubernetes and all that good stuff, which you're going to also look at. We have DCOS. It's also like a containerization tool. We have different cloud environments, just like I said, AWS, Azure, and all that good stuff, where your application is actually going to be deployed to, and then various people can have access to those applications. And if you have the question in your mind, like, why go through all this stress? Why do companies do all this? Why do we have to do all this? Applications like Instagram get up to 1 billion requests per second. 1 billion people, like 1 billion different requests are coming into an application like Instagram per second. I can guarantee you that if 1 billion people try to reach out to redluxconsulting.com, if it's not hosted on the cloud, I can guarantee you that Redlux Consulting will shut down because it's having more requests than it can handle, right? So, but for applications like Instagram, Facebook, your banking app, and different other applications that need a lot of read and write requests at every point in time, available 24 hours. That's why it doesn't matter what part of the world you're in. It doesn't matter what device you use. It doesn't matter what internet connection you use. If you go to your Instagram and you want to view a photo, you're going to get that photo. If you want to log into your bank app, you're going to get that bank app and all that good stuff. I've read about situations where I know, for instance, a clothing store that signed Nicki Minaj, and Nicki Minaj talked about the clothing store during her show. Thousands of people went to the website crashed. I went to a concert one time. I used Ticketmaster to purchase the concert ticket. When you get to the concert, you log into Ticketmaster and they scan your ticket and you get into the concert. If Ticketmaster wasn't hosted on the cloud, everyone has, let's say, 2-3 months to purchase the ticket. But on the day of the concert, when everyone is trying to log into Ticketmaster to pull up the QR code for people to scan, if Ticketmaster is not on the cloud and they don't have scalability available on their application, when hundreds and thousands of people try to access Ticketmaster, that feature that generates the QR code, Ticketmaster is going to go down, and then the users won't be happy, and that's how businesses go, and that's how companies go out of business. So you can see that it's a very interesting, delicate, and important process, and that's why companies spend millions and billions of dollars just to ensure that they keep the application running. They have auto scaling on so that they can accommodate requests. They have disaster recovery on. For instance, if you don't have disaster recovery on, let's take Zenith Bank, for instance, or let's take a Canadian bank, CIBC, and they have or Scotiabank or TD, and they have their database running on-prem in their head office in downtown Toronto. And, there's a fire incident and the office in downtown Toronto gets burned down. That means we've lost all our data. If you had 100 million naira in your, $1 million in your bank account, and CIBC downtown Toronto, where the data center is, burns down, your money is gone. So even in IT policies now, there's a requirement for high availability, disaster recovery, and all that. And companies must have to, they must have to kind of conform to those policies. And that's a whole different That's a whole different part of IT, like policies and all that, auditing and all that good stuff. All right, so that's all that has to do around deployment, how you actually deploy your app on different cloud platforms, and how you make sure that it meets some criteria like auto scaling, high availability, disaster recovery. Sometimes you can access some apps from different locations, those features as well. You can get all that features using different cloud providers like AWS, Azure, and Google Cloud. All right, now we've deployed Red Loss Consulting on AWS. Everything is looking good. The color has changed from red to blue. The image looks good as described. Nwokoye is happy with her new website. It has auto scaling. It's highly available. Disaster recovery is on. Nwokoye is happy. But someone has to be sure that, as people are accessing that website, people are accessing that application, the memory, the IOPS, the database is not running out. It's highly available. If you click on the link, it gives response. It's highly responsive. For instance, if you don't want people from certain parts of the world to access it, that is in place. So it's more like operational, every day-to-day operational, to monitor the day-to-day operation of the website. So there are other tools like Chef, Ansible, Kubernetes as well that DevOps team uses to kind of make sure that that everything is working as planned. So operation and monitoring, they're practically almost the same, but operation mostly looks at the back end, like looking at internally the size of the database. So let's assume we started with a 5 gigabyte database. A lot of people are coming in, registering. It may get to a point where we can recommend, hey, I think we're gonna exceed our 5 gigabytes space in the database. Then you can make a recommendation to kind of improve the database to a 10 gigabyte, 20 gigabyte, and all that good stuff. That's where you don't have auto scaling for database. That's all under AWS. Or you can see that your CPU usage is going high at certain points in time. For instance, if you're running a gym application, people might be using that app mostly in the mornings and in the evenings. And then you're maybe on an on-demand instance. You can, hey, look, you can say, well, people use our application from 8 a.m. to 12 p.m. So from 1 p.m. to 3 p.m., no one actually uses the application then, but from 4 p.m. to 10 p.m., this is also when we get a lot of people using the application. So you can make some recommendations to your company to say, hey, why don't we use, on-demand instances from X time to Y time, then use reserved instances from XY this time to that time, and then use spot instances from this time to this time. It could give us a 20% or 30% reduction in operational costs. So all that good stuff, you're going to use tools like Chef, Ansible, Kubernetes to get those data metrics that you use to kind of fine tune your application and kind of lean more on cost optimization and performance management, basically. And then finally, you have monitoring. This is real-time monitoring of your web application, the way people are using it. We have different tools like Datadog, Splunk, and other tools that you can use to kind of get real-time analysis on your application, the amount of people that are visiting at every point in time, their IP address, their location. And then you can use that to make some decisions like target advertising. So people in Nigeria will get some kind of content, people in Canada will get some kind of content. And that's how you ask some questions. Oh, why do I see XYZ on my Instagram? Or how did my bank know that this is going on, It's from all the data that they get from real-time monitoring of the use of the application. Then they can use that to kind of channel different content to different users. Okay, so high level overview. Does it mean I'm just looking at the chat. Does it mean when you have a DevOps engineer in a project, a QA tester is no longer needed? Nope, that's not what it means. And again, we'll definitely look into this on the next slide. There are different roles, different people do different things, and they all work together to ensure the efficient and effective delivery of applications and our web applications as well. So any other question before I move on to the next slide? No questions. Cool. All right. So
Hello, sorry, I have a question. Hello. So like you were saying, like for cloud, like AWS, Google Clouds and all that, like compare with companies having physical data centers in their companies where there could be some vulnerabilities, like maybe in events of fire. So does it mean that cloud services don't have any vulnerability?
Great question.
Like nothing can happen to them. It can never go down, or nothing can disrupt the data or what we have in the cloud.
Very good question. I'm sorry I didn't get the name. I'm only seeing
Oh,
Pamela.
Bookie.
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 Okay.
All right. Very good question, Bookie. So Bookie's question is, we talked about on-prem data centers and some of the risks associated with on-prem data centers. And Bookie's question is, does it mean that there are no risks associated with cloud, storing your or running your applications on the cloud? Yes, there are risks associated with running your applications on the cloud. However, Bookie, there are mitigation plans in place to ensure the integrity of your data and ensure that your application doesn't shut down when those things happen. So let's take a fire incident, for instance. You have an application, let's take a banking application. So your Scotia Bank application, you have it running on-prem in Scotia Bank head office in downtown Toronto. 1 million people use this application. You have your database, your networking is all done on-prem. Everything is there on-prem. So one day there's a fire incident and the Scotia Bank Plaza downtown gets burned down, which means 1 million users will lose their data because that data is in hardware machines, stored in the data center. The networking are all cables connected to each other in that data center, which means everyone is going to lose their information, everyone is going to lose their data. Now, how does the cloud work? The cloud is also a combination of different physical data centers, right? So people like AWS, people like Microsoft, people like Google, they go around and build data centers. As a matter of fact, there are lots of data centers that they build under the sea, in the ocean, right? And then they connect these data centers using very fast cables. If you can remember back in the day, there was a whole conversation around fiber optics, right? So they use this fiber optics cable to kind of connect these data centers together. So all around the world, they have different locations and different hundreds and thousands of data centers. So they're called regions. When you come to AWS, a collection of those data centers are called availabilities. Before we get to regions, they're called availability zones, AZ. So let's assume in Toronto, Amazon has 200 data centers connected together. In Calgary, they have the same. In Ottawa, they have the same. So they break those things down and call them availability zones. Now, what happens to your data to have data integrity, to have high availability, is that when you store your data in one AZ, in one availability zone, remember we have hundreds of physical data centers connected together. So let's assume Scotia Bank Plaza is one data center. A building two blocks away is another data center. Another building is another data center. But all these data centers are connected together using high-speed fiber optic cable. Again, not accessible over the internet. if Scotiabank should store their information on AWS cloud, even if the one building should have a fire incident, because your data is now practically in the cloud, nothing is going to happen to that data. So there's no data loss because it's not stored in just one data center. It's replicated across all that data centers in that availability zone. And that's how they keep replicating that data, not just across the availability zone, but what we call a region. So there's AWS region. There's, US East 1, US East 2, CA Central 1, Central 2, Korea, South Africa, different regions, right? So your data will be replicated across multiple data zones, across those regions, across those availability zones, and across the region. And that's why we call it high availability. But let's also take an instance where it's not even a fire incident. Let's take that we have an atomic bomb. Someone drops an atomic bomb in the whole of Canada, right? Which means those physical data centers, thousands of physical data centers that AWS has in Canada will all be lost. So everybody's data will all be lost. To prevent that from happening, there's something we call disaster recovery. So instead of storing your data in one availability zone and one region, you can store your data in multiple availability zones, which is a best practice recommended by AWS. Now, it doesn't also give you high availability, which means your data will be easily accessible because, again, it's stored across multiple regions and multiple AZs. In case of something like an atomic nuclear bomb, hitting Canada and the whole of Canada is wiped out, you have your data stored in maybe US East 2. So, which means hundreds and thousands of data centers across the United States, right? So your data will still be available in the US. And if you have disaster recovery set up, there's a process in place that automatically, if this AZ or region goes down, your application will automatically switch to the next AZ or region. So your user won't even know where your data is located. There won't be any impact on your user, and you've successfully mitigated that risk of losing data or information when there is a disaster. But that is all AWS. That is not DevOps, but good thing that I have that knowledge. So does that address your question,
thank you very much.
Vicky?
Yeah, I completely get it. Thanks.
Awesome. All right. Any other question? Before we go to the interesting part, how do we make money? How do we take the best of this knowledge that we have and convert it into cash? So as you can see from this slide, there are different roles or different career opportunities in DevOps. The most popular one being the DevOps engineer, as you can see here. But outside of DevOps engineer, we have DevOps enthusiast. So the same way we have like your agile coach or your there's another name they call it. No, yeah, I can't remember. People that kind of promote agile in an organization.
Evangelist.
Yes, agile evangelist, agile coach, and all that good stuff. In AWS, I can't remember what we call them. There's one we call serverless stuff. Anyways, so there's DevOps enthusiast, more like someone in the company that's going to be talking about DevOps, educating leadership and other teammates about DevOps, and trying to kind of push the whole DevOps narrative in the company and answer questions around DevOps or how to kind of recommend the DevOps practices in the organization, and just continue to keep everyone educated and updated around DevOps. So that's one role in DevOps that anyone can kind of research. And if you feel like it's something you want to go into, there's a roadmap for that as well. There's a cloud architect role. So let's go back to the previous slide. I think it's going to make it easier for everyone to understand. So there's a cloud architect role. So a cloud architect mostly focuses on building the infrastructure where the application is going to be deployed in the cloud. So just like Buki asked, and just like we addressed in the previous conversation, someone is going to be responsible for setting up all those permissions, high availability, disaster recovery, security in the cloud, making sure that the right IP addresses get into the right application, WAF to prevent DDoS attacks, auto scaling to make sure that the application accommodates however the request comes in, cost optimization to make sure that the right resources are being used, and all that good stuff, all the way down to machine learning, artificial intelligence, integration, APIs. So all these are done by what we call a cloud architect, and that's the design, not the implementation. So the cloud architect will draw the design, so high availability, disaster recovery, and all that. Then the cloud engineer will then write the code. So we have like Terraform for infrastructure as code. We have CloudFormation, that's mostly associated with AWS. But you can see that the roles are, it's not one person does everything. Even the design is done by the cloud architect and the implementation is done by the cloud engineer, right? So that's another role that you can look into if you want to get into like DevOps and cloud. So to get in that, there's also a roadmap. You can start with AWS, you can start with Azure, Google Cloud, whichever one is your preference. But yeah, it all falls under like the deploy stage of the CI/CD process. There's a quality assurance person. So the QA person, again, simple and straightforward, is all around quality assurance. And the QA person falls more under the test portion of the CI/CD process. And just like we mentioned before, previously, the QA person has to review the business requirement document, manually look at the code, or maybe when the application has been deployed in dev or UAT, the QA person has to manually figure out if everything works as documented in the business requirement document or the functional requirement document or whatever the document the organization uses. But as a QA person in DevOps, there's no manual intervention. Rather, you learn how to write what we call YAML codes. So it's called .yaml. It's just like Python, HTML, CSS. It's very simple. It's a key pair methodology of writing code. So, for instance, color has to be XYZ code. Image has to be XYZ. Those criteria, you write it as code and you upload it to what we call a build spec in this Selenium or JUnit or whatever application that the organization uses. So you upload your build spec YAML code so that when the developer pushes the code, automatically it verifies that your build spec, that the requirements in your build spec meet the requirements in the code. Again, no manual intervention. And if everything passes, it goes on to the next stage. And as you can see, if it's going to take the developer five weeks to build the code, because you guys, just like the first question, I can't remember, I think Emmanuel asked, because you guys have that documentation, you can build your build spec under 2 days, upload it, and that's it. So your developer doesn't need you to be available to run the code. You don't need to be there. You're not waiting on anyone. No one is waiting on you. And that's the whole idea behind DevOps. You have a release coordinator as another role in DevOps. So what does the release coordinator do? After the code has been written, tested, and all that, you won't just say, okay, fine, let's release, right? What if you need some downtime? What if it's a database improvement? You're running on a maybe GP2 database. Now you're running out of data storage space, and you need to improve to a GP3, 5 terabyte, 10 terabyte. And again, don't forget 1 billion users are accessing, reading and writing on that database. Sometimes you need to shut down the database for a couple of minutes, seconds, right? You need to have a cutover plan in place just to make sure that data is not lost. Maybe you want to migrate data from a different database application to another database application. Maybe you've merged with another company. You need to bring in that company's data into your own database and all that kind of good stuff. So that whole process of planning the release, managing downtime, cutover plan, mitigation plan, and all that good stuff, that is where the release coordinator comes in to work with the team, write the plan, review the plan, make sure that all the timeline. So sometimes you see your app, your banking app, it will say, oh, maintenance mode. This application will not be available from so time to so time. Those are all the functions of the release coordinator, making sure that communication in place, making sure that you stay within that timeline that you've communicated to your users and all that good stuff. So any question? I think someone asked the question if you needed to know all these tools and how things interject. Am I answering your question? Okay, maybe the person dropped off. And now we have the most common role, your DevOps engineer. So the DevOps engineer is practically the guy that knows a little bit about everything. So the guy knows about version control. The guy knows how to write some software code. It mustn't be everything. You might just know how to write Python code. I always recommend Python because Python is like very flexible, runs on AWS, runs on Azure, runs on Google Cloud, on different kind of offerings. Like on AWS, it runs on Lambda. Doesn't mean that other tools don't run on this platform. But personally, I prefer Python. And if you want to kind of get into the DevOps engineering role, I recommend learning high-level Python because it comes in handy. And again, we have CloudFormation. You write templates. Don't forget, everything is automated in CI/CD. No manual interference from the day you push the code. So from when you merge the code in Git, right? So when you merge the code in Git, it's going to document in Jira. It's going to automatically, because you're going to build Maven, or let's even assume you use VS Code, which is a more recent, or will I call it a better application. From VS Code, you can click on push or pull request, whatever. Automatic goes to Git, kicks off the process of testing, kicks off the process of release, all the way down to deploy, right? And it keeps going on and on. No human intervention, no human interaction. Everything is automated. So the DevOps engineer, going back to the careers, is someone that kind of has a good understanding of, not 100% detail of everything, but well, the person knows about Git, the person knows how to write a couple of code, the person can just view and understand a test case, like a code build test case, sees that okay, these requirements must be met, and kind of translates it to the engineer, because in my experience, some engineers might not speak English. Some might not really know so much. So the DevOps engineer will be able to say, okay, just make sure that the color meets this, make sure that X is Y and X, Y, Z, right? Same as the release, just make recommendations to whoever is the release manager, make sure that everything has been met. Same as AWS, have a high level understanding of AWS, how things work, can translate like solution design diagrams and all that. Doesn't have to have deep expertise or experience in AWS, but just knows how things work and can translate on a high level some of the recommendations. And the same as operator monitor. So that is why the DevOps engineer role is very common, because the person works with, lots of other teammates in the whole DevOps lifecycle, and it's a very common role. Then you have the security specialist. Again, because things are running in the cloud, DevOps is recommended that DevOps has to do with cloud. I mean, there's DevOps in on-prem, but it's something that you rarely find. Most DevOps, most applications in DevOps run in the cloud. So because it runs in the cloud, we all know about the cybersecurity threats, people trying to hack different people's applications, websites, DDoS attacks, and all that good stuff. You need a security specialist that will kind of ensure that the security of your application when it has been deployed in the cloud. And if you have the question, well, I thought cloud is better than on-prem. Why do you need a security person? In the cloud, there's something that we call a shared responsibility model, which means AWS, Azure, Microsoft, Google, they are responsible for the security of the cloud, And you, the user, you're responsible of security in the cloud. Typical example, if you live in a condo, your condo management is responsible for the security of the condo. So ensuring that your cameras in place, the entrance, there's a fob in place to make sure that only the right people have access to the building and all that good stuff. But you're responsible for locking your door, right? So that's just a practical example of security off the cloud and in the cloud. So you need a security specialist that will ensure that these best practices in security are in place. You may have IP addresses that you may want to block out of your application. There's something that we call security groups in AWS that we use to manage that whole process. So you need a security specialist that understands cloud security to be able to meet the requirements of your application when it's being deployed in the cloud. Okay, so we also have software engineer or software producer, which is also a career in DevOps. The guy comes in all around the code and build stage. This is the person that's going to write that code to convert reglux color from red to blue. So whatever feature, whatever applications you guys want to build, that is where the software producer or software engineer comes into place. And as you can, as I believe everyone knows, this is one of the most creative roles in IT. So if you know how to write any code, for instance, Python, JavaScript, Node.js, Golang, this is where the person comes in to kind of interpret user stories or features or whatever you guys want to implement as code. All right, so this is like at a high level, some of the careers that you can chase in DevOps. This doesn't mean that this is the only roles that we have in DevOps. There are so many other roles, and if we want to cover all of them, I can tell you for a fact that we're going to spend another 2 hours on this presentation. Don't forget, this is just an introductory course, and I think I did more than introduction. I gave out a lot of information.
They did justice, they did justice to the cost.
Yeah. So what's the industry outlook? You can again go to glassdoor.com to kind of get a more detailed information around some of these rules. So you can go to Glassdoor, just search for DevOps enthusiasts salaries in Canada, in US, whichever country you're in, or cloud architect salary in Canada, US, or DevOps quality assurance salaries, stuff like that. So that gives you a good overview of a good understanding of the range of compensation. The little research that I did from what I looked at, the base pay for a DevOps engineer in Canada is from 78K to 107K per annum. So if you want to look into that, again, glassdoor.com, I'm sure all of us know Glassdoor. You can get more information about, the industry, how many roles. There are hundreds and thousands of roles in DevOps open currently out here in Canada. So feel free to do that research on your own, and then you can figure out what role you want to kind of fall into from this kind of overview, and then go through the career path, learn the skills that you need, and in a couple of months, I can assure you that you're going to land yourself a role in DevOps. So thank you everyone for your time. That brings me to the end of my slide, and I'll be passing it over back to Nwokoye to.
Thank you. So please, for those who are on the call, please, if you can use your emojis to give our facilitator a huge shout out. So if you know where your emojis are, please. You know, I always tell people whenever I do these facilitations that, you know, like we're doing it for free. So what we just need is encouragement, you know, shout outs. And for some weird reason that Zoom is doing, do you know everybody's name is showing my name? It's just a few people that I can tell who their name is.
I was going to ask how I suddenly changed to power.
Like I can't even figure out what happened. Like everybody has my name. At the point I was like, this like it's some ridiculous thing. Everybody is Pamela. Like I don't know. I have to go and check what happened. It's only happened to me. So that's why when people sent messages, I didn't know who it was, but I picked some voices. I could tell Emmanuel's voice. I could tell Bookie's voice, and I think I heard Bookie. I'm not sure the other Bookie, the male Bookie. I heard Bookie about his voice, and I heard the other Bookie's voice. So I was like, okay, I think I know who's on the call. And again, I wanted to. Yeah, exactly. So see, I know voices. And then again, I needed to do time check for Ben. I could not do it because his name was also Pamela. So I was like, I don't want to go and send it to the wrong person. They will be like, what's all this? Okay, so thank you very much, Ben, for putting this together. So I just really want you all to know that a lot of things that we're doing for our community is to make sure that information is available and free. It's no longer the time of I did not know, I did not hear. And I'll tell you, how did this come about? I don't know, Ben. I've probably seen Ben only on a few calls like this, or I don't think I've even seen him in the last few weeks on the call. But it's just like, hey, I want to do this. I want to share this information with the community. And he volunteered. So I just want you guys to give me a round of applause. There's no payment. He does not work for Red Logs. I don't work for him. We're not colleagues. This is something that he did for the community just by me as saying, I need to do this training. I need experts. So I want to thank him very much for putting that time. And he truly, truly, truly did a lot of justice. Because what I'm trying to do, I'm trying to empower people to have more opportunities. One of the things they're going to notice is that even though my areas of expertise are in project management, in Scrum, and business analysis, I've also had, you know, multiple tech roles. And I'm being a project manager. You work with a lot of different technology teams. Like in a project, I'll probably work with the digital team. I'll work with architects. I'll work with risk assessors. I'll work with cloud people. I'll work with people who do DevOps. I work with all kinds of people, right? So I touch a bit of everywhere. And so I believe that we need to make sure that we're giving people as much information as they can so that they can figure out what parts of tech they want to get into. And so that's why I'm calling it Get Into Tech. We're going to be having a lot more monthly sessions to uncover technology roles. So even if some of them don't interest you or they're not for you or you figured out what you want to do, I'll still encourage you to join and listen in, or send it to your friends or your family so that they can come and pay attention and get more information for free. Because at the end of the day, someone might say, hey, before you consult me, you're going to pay for me to talk to you. But imagine this is 2.5 hours of free information. So watch out more. We'll be rolling out a lot of new programs as a company. So we would send you more information about what programs are coming up. But if you have any questions, feel free to respond to the email, the registration email that we sent. If you have any questions for Ben. Ben, you didn't give them how to connect with you. Like, did you put your contact details?
No, I just shared my LinkedIn URL. So feel free to follow me on LinkedIn. The URL is in the chat of this call. So yeah, feel free to reach out to me at any point in time, and I'll be happy to respond.
All right, great. So we're going to send also like a survey just to see how you felt about the training. If there's any sort of follow-up that you need, we'll be able to do that. Someone's hand is up, and I think that's Emmanuel. Do you have a question, Emmanuel? I'm not sure if Emmanuel, or it was from your time when you were when you were clapping for our amazing facilitator. So I don't know, are there any other questions from folks before we call it a day?
I have a question.
Hello, Pam. So
Okay.
sorry, I was trying to yeah, I actually have not just like a reaction. I was trying to leave the LinkedIn because I quickly clicked on the LinkedIn link to connect to him. So, but I was trying to get back to the main page again, but my screen was just acting up. So just a reaction really, because I mean it's quite amazing what you're doing, and I mean you and your team trying to selflessly, I mean, do this, put out, you know, trainings and you know, informative sessions that typically people would have, you know, paid a lot of money to access, and then you're doing all of those things for free. You're even chasing people to come for, you know, free events like this. I mean, it's quite amazing. I've not seen that before, and I'm seeing great kudos to you and your team for making this happen. And again, to our great facilitator, from me, it's a great thank you, because I mean, away from someone who is being in tech and who understands maybe some of the terms you're using, the way your delivery was so impeccable. I mean, for someone who is a novice, they will totally understand you know, stuff about all the things you said here today. It was so, I enjoyed every moment of this session, and you know, thank you so much, and God bless you for, you know, selflessly you know, impacting other people. You know, thank you so much, and God bless.
Thank you. I really, really appreciate it, Emmanuel. Thank you for always attending all these sessions. I know that you attend a lot of these sessions as much as possible. So thank you. And my prayer is that everybody, like all this information that we are getting, would actually, like, one day are going to say, you know what? Thank you for all of that information I was getting all that time. It eventually paid off. You know what I mean? That's like the idea, is that this information would tangible in terms of roles, in terms of salary increments. You know what I mean? That's the idea. At the end of the day, the result and the outcome for people. Thank you so much, Emmanuel. All right, over to you, Buki.
I think Emmanuel said all the things I wanted to say. It's a great session. My question to Ben would be that for someone in QA that wants to go into that QA, the automation part of it, is there any recommendation as to training, or how does one follow that?
Hey, yeah, that's a good question, Buki. From my experience, there are some tools that, again, QA specialists use to kind of automate that whole process of quality assurance. I don't know your current role and how you perform your QA task, but I want to just guess, and again, correct me if I'm wrong, that you go through some of those acceptance criteria and maybe manually validate that those terms have been met, right?
Yeah,
Okay.
I'm a manual tester.
Exactly.
Yeah.
So that is totally fine. That is applicable in Agile and some other kind of methodology. But when you get into DevOps, the goal or the idea is kind of automate the whole process. So to fully answer the question, I'll recommend kind of learning some of these tools that companies use to automate the process of QA testing. And I also recommend learning how to write a YAML code. I've seen some videos on LinkedIn that kind of give some information around the whole process of CI/CD testing. There are some tools like Selenium. I know in Terraform we use, what was that tool called again in Terraform? I can't remember now the name. But yeah, all you do is you write build specs, in YAML, and then upload them to those tools. Just the same thing you're doing manually, just to automate them and upload them into those tools so that when the developer pushes their code, it goes through, the whole test process automatically, and you don't have to manually interfere in the process. So maybe do some research around the tools, just learn how to write YAML. It's very easy, something you can learn in 2-3 weeks. It's a key value pair kind of coding, just like CloudFormation, and that's it.
Thank you.
Yeah, no worries.
I went on mute. So thank you, everyone. Thanks, Ben, so much. I really appreciate you coming. I want to thank everyone who showed up. You registered and you showed up. So that means that you are really serious about a career in technology. Thank you all for trusting in the work that I do. And, keep on watching out on this space. A lot more information, a lot more webinars, a lot more opportunities, a lot more training will be coming out from here so that we can make our community much stronger. Like, we have to become the powerhouse of technology, at least in Canada. So that's the idea. Like, when they say, oh, the Nigerians, they'll be like, whoa, the Nigerians, they're very strong in technology. That's the goal. Thanks, everyone, and have a great Saturday.
Okay.
Thank you. Bye.
Thank you. Bye.